Hello, hello. So, welcome to today's POTD video. First, we understand the question and then we see the intuition behind it and then we code the intuition that we seen. Okay. So, our question name is nearly sorted and it's a medium level of question according to them. So, we have given an array ARR where each element is at most k away from its target position. You need to sort the array optimally and do not use the library sort function. Okay, so they are given us that each element is at most k distance from his correct position. Okay, and we have to sort the array without using the library sort function, because if we sort the complete array then it is got sorted, and we have to like do the change in the array itself that they given us. We don't have to return anything because the function is void. Okay, so as I see the first example, then what they are given us, that is 6 5 3 2 8 10 9. Okay, so it means the 6 is 3 distance away from its correct position. So 6 1 distance is still 5, 2 distance is still 3, and 3 distance is 2. Okay, so at most 3 distance means it in this range 6 should be lie in the sorted array, and we can see that 6 is at the last position. Okay, and 2 is at the first position. So that thing that we have to maintain, that an array element is at most k distance apart. Okay, so let's understand the first example that they are given us. Okay, so this is the example that they are given us. Okay, so what we can do in this, that okay, we know that कि if an element from this range come to this position. Okay, so this range is what, this range is like k plus 1 element I have taken in this. Okay, so why k plus 1 element? Because k like we can see that 6k distance till 2. Okay, so it means still like elements should be k plus 1 and distance is k. Okay, so if the element that is came here is in this range only, because like k distance we have to maintain, no? So that's why the element that is the smallest element that is came here we have to find out. Okay, the next thing we have to do is that we have to keep in mind the three elements that are remaining here, and one element we can or more add,
One
and we
is how do we
find the minimum
decide
element
who will
from
be
them,
on the
and
face
then
of a node?
that we put at the
Like
second
in
position.
America, they keep
Again
changing
the
the
same thing we
presidents,
do,
right?
that we add
Uh,
the new one element
and
from the
in India,
previous
we have
element.
Mahatma Gandhi ji,
We find the
but
minimum
there's no one else.
element
So
and
how do
we
we
add
decide
this
who they
position.
are?
Okay, so
We can't
that thing
agree
we
on that,
have
I
to do in
guess.
this. Okay, so
uh,
why
look,
I am
I,
But
choosing
who
this
decide? Like it's
approach?
been decided
So
and they just
let's
keep going on.
understand it
Nobody can introduce new
more
thing. Like what's the
better.
I
policy
think
behind it?
I
That
think so.
what I am
We did
exactly
design
trying to
some new
say,
nodes, but
that
in general, the
this is
sense
the given
was
array. Okay,
you can
this
tamper
is
with
the
the
given array
color, you
that
can
we
tamper
are
with the size,
given.
but you can't
So why
tamper
I'm
with the
saying that we
face.
have to find out the
Because
minimum
once you pick
element
a
from these.
face, it
So
becomes
if we
very, very
sort the
controversial.
Yeah,
these
We would
elements, then what
ideally
they are
like the
become
UK.
2, 3,
You
5,
could
and
bring
6.
in
And
sort of
according to me, that
scientists,
I am saying that
social reformers,
k प्लस वन एलिमेंट्स में से
prominent
ही सबसे
historical
शॉर्टेस्ट
figures,
एलिमेंट जो है
women.
वो यहाँ पर आएगा.
But we need
Okay,
some agreement.
so that I have to do. So 2 is
Nobody
come
knows
at
what
this
Ashoka looked
position
like. How
then.
do you put
Okay,
Ashoka? And then there's
and
controversy about
next thing what I have to do, that I have to remove this from our group because it already got used, and we take the next element. So next element is 8. Okay, so then the smallest element will come at this position. We remove the smallest one again we take the next element, that is 10. Okay, so now the 5, so 5 we are take, and we remove that from our group. Then what the remaining is the ninth 9. Okay, so 9 we add in this, so then the sorted element will be in this order, that is 6 8 9 10. And next we can take is 2 3 6. Next we can take is 8, because now I am not able to add more element because I reached at the end of the array, and this is the sorted array that we want. Okay, so it's good work. So as you see that we are taken and taken the minimum element, so it's more like of the min heap. Okay, so that's why I am using here min heap for this purpose, for finding the smallest element at this position. And what I am doing, that each time I removing the first element, again removing the top element, and I am putting that in our array. Okay, so that's the intuition behind it. Let's see the code, or let's understand one more example, that if we are given 3 2 1, and they are given that k is 2. Okay, so what it means, that we have to choose the three elements. Okay, so they are given as three elements, push those in the min heap, and till the min heap is not go to empty, we are taken the one, remove this one, and we point the initial pointer here, that is out of bound of array, so we don't need to add anything. Then we again take the top element, remove it, again take the top element, remove it. Now our heap is become empty, so this is our answer. So this thing we have to do, and let's see the code right now. Okay, so this is the mean heap that I am taken here, and these are the k plus one element I have taken. So, less than equals to k is never goes out of the bound, because they already said that k element is from one to array dot size. Okay, less than array dot size, not till array dot size. Okay, so that's why I can take less than equals to k, because k is still n minus one, and take the element j equal to 0 for setting the element at their correct position, and I to the k plus 1th element, because we have to add also. Okay, so first I take the top element, remove that element. Okay, and then I add the more element, that is k plus 1 index or more, and I add only if it is in bound. Okay, and again I am increasing the jth pointer. So jth pointer is for array putting elements. Okay, so that thing we have to do. Let's compile and run the code, that it is running fine or not. And if I'm compiling, it's like saying that it is in queue. Why it is taking so much time, I don't know. Let's directly submit it, like if it is got accepting or not. Previously I ran this code, same code, so it is got accepting. So currently I think that my net is slow, that's why it is remaining in the queue. Let me try one more time, that it is got accepting or not. It is remains in the queue. So I think the code is same and it got accepted. So that's my solution. Thank you.